y'all. One more little short video to bring you up to speed with what you missed for the power outage today in Math 133. We're looking at proofs of the triangle angle sum theorem. So let's switch on over. Here's another neat proof that you can use to prove why these angles in a triangle sum to 180. So let's just start here by naming the angles A, B, and C, and reminding us that our hypothesis, right, what we're trying to show is that A plus B plus C has to equal 180, right? And this one is kind of interesting because it employs what we call exterior angles. So if we continued the side of a triangle on, then this angle is called an exterior angle. Let's go ahead and name those right away. Let's just say that since we've got A, B, C, let's call this one D, E, and F, right? So right away we can see that in this setup we have a straight angle here, a straight angle here, and a straight angle here. So if we were to do a proof of this, and again I'm going to just do kind of a proof sketch with not a lot of words around it. The idea here would be that, let's see, A plus F is equal to 180. C plus D, it's got to be 180. And B plus E has got to be equal to 180. And all of these are by straight angle, right? So that's pretty straightforward, but it really doesn't get us any, what we really want is we want, A plus B plus C. I mean, we could find an A plus a B plus a C in here, but the problem is we've got an F, a D, and an E in there, right? So I guess we should go ahead and just add them all together. Everything on the left will add, and everything on the right will add. So I'll just say A plus B plus C, that's this and this and this, plus D plus E plus F. That's all got to be equal to 3 times 180. So 3 180s adds up all 6 angles, which makes sense because we have 3 straight angles. But the big question is how can we get rid of the D, the E, and the F, right? Because what we want to show is that A plus B plus C is only one of these 180s, right? So really what we need to show is that D plus E plus F is 2 180s, and that's what we're going to do with Ron Weasley. If you're surprised, here he is. There's Ron Weasley. My daughter picked one of her little guys from our Lego Harry Potter set. This is Harry Potter's best friend if you're not a Harry Potter fan. And we're going to argue that D plus E plus F is equal to 360 by walking Ron around this triangle, okay? So let's say Ron starts right here, and he is pointed, right here, he's pointed towards this other side, right? So if Ron walks around the triangle, he goes to this other side, and then he rotates himself by an angle of D. In other words, he rotates by that angle D to get ready to walk down the other side. And then Ron walks down the other side, and he gets to right here, and he says to himself, okay, I want to keep walking around the triangle. I've got to rotate myself then towards this side. And of course, he rotates now by an angle E, right? And now he is pointed at his home base here. He's going to run back down to the last spot where he was. But in the last step to end up the way he was, he has to rotate an angle of F. And so now we see that Ron is pointed in the same direction, but he's rotated through D, E, and F to get himself to that pointed in the same direction. So I guess what we can say is that for Ron to come back to this point, when he rotates by D, E, and F, he's gone a complete revolution, right? So in other words, Ron has walked around, whenever we walk around a figure, we rotate by 360 degrees. So I would say something like by walking around the triangle, we can see that what F plus D plus E is equal to 360. And really the reasoning there is just that, when you walk around something, you rotate each one of these turns at a vertex has to add up to 360, because in the end you end up looking facing the exact same direction. And this was about where we got in class. We sort of had these all of this I guess information, and the question was, well, how do we finish it off? And we'll finish that off first thing on Friday, and we'll see you there in class on Friday. You're all caught up?